Okay, so the lecture for this video is Python types, variables, and input-output operations. So I'm going to very quickly go through the slides, and then I'm going to do an example as well. I won't be coding the example, but I will walk through the code. So programs at a high level tend to receive input from a variety of input devices. Could be a terminal prompt, could be a file, could be a sensor of some type. They do something then with that input. Okay, and these are the four operations that programs do. They either, do step 1, step 2, step 3, sequential processing. They do something based on a conditional. If some condition is true, do something. They can loop, or they can call other functions and sort of delegate their work to someone else. Okay, and then finally they produce output either to a screen, a printer, or some other device. Okay, so this three-step process, as we talked about in the programmatic problem solving lecture, okay, tends to happen over and over again. And as you're designing your programs, you can think of things this way. Where am I getting my input from? What do I have to do with that input? And how do I transform that input into the output I need? So if you constantly are asking those three questions, that really helps you with some of your design decisions. Okay, variables are actually a completely different concept in computer science than they are in math. Okay, so in math, a variable is an unknown, where in computer science, a variable is a known concept. Okay, it sounds a little strange, but once you get used to it, you understand it. All variables have four things. They have a name, a variable name, a type, which could be integer, string, Boolean, whatever, a value, and a memory location. So here is an example of three different variables, x, y, and z, in three different areas of memory, and each with three different values. Okay, the basic Python types are shown here. Integer is exactly what it sounds like. A float is a decimal number. There's no such thing as an irrational number in computing. So a float is a rational number in decimal form. A string, which is a series of characters, can be numeric, can be alphabetic, can be anything. A Boolean, which takes on the values true and false, and none, okay, which means it does not have a type value. As we get later into the course, we'll see that there are some other types as well, but these are what's called the primitive types, or the primary types for Python. Python's a dynamically typed language, okay, which means that the type of the variable can change depending on the value that's being stored. Okay, so a program like this, or a series of statements like this, are completely valid in Python. So we can set the variable x to 3, then print out 3 plus 46. It would print 49. Then I can change the variable to some other type, like a string, and this would print out hello, hello, hello. Okay. Most other languages do not have this feature of dynamic typing, and it's important to understand that Python does, because it can really impact the way your programs run. Okay, so there's all types of rules for naming variables in Python. And the actual Python rules are at the top of the screen. My rules, or the things I prefer, are at the bottom of the screen. Okay, so I expect that variable names will start with a lowercase letter. A variable name will be descriptive, okay, but not too long. Oops, sorry. Okay, so a variable will use camel case, which means after the first word, the first character of any subsequent words in the variable name will be uppercase. We will abbreviate consistently within a program. So if we're going to abbreviate number as num, that's perfectly fine, but do that consistently. And should we use name constants, which we're not going to use a lot of, they should be all caps and with words separated by an underscore. Equals is an assignment operator. Okay, so it's not a comparison operator. When you use the symbol, just a single equal sign, you're actually storing something in a variable. Sometimes that variable will have to be created if it doesn't already exist. Okay. The right-hand side, RHS, right-hand side of an expression is always evaluated first. This is the same in Python as it is in pretty much any other computer language I can think of off the top of my head. And then the value is saved in the variable on the left-hand side. Okay, so what that means is this command will be executed and will run, and then whatever has been typed in at the terminal, okay, will be stored in a new variable called input name. Okay, that'll be created. This, however, makes no sense because what the computer would try to do is evaluate the y, which might be a valid variable, but it can't store that into 5 plus 7. That doesn't make any sense. Okay, notice that the equal sign is used to assign all kinds of things, not just arithmetic results. Okay, so strings, input values, responses from functions, all those things are use the equal sign for assignment. Input is a particular function that prompts the user at the terminal prompt for a single line of input. Okay, by default, input stops when the user hits the enter key. Okay, so that means if you put spaces in your input, those spaces will appear in whatever gets stored in the variable name. Okay, so if I have something like name equals input here, and I just type in April Edwards with a space between, name will then be assigned the value April Edwards, spelled out as a string. Okay, input always returns a string. Okay, and if you don't want it to be a string, then you have to convert the variable type. Okay, there is a second version which we use fairly often that takes a prompt. Okay, so this would actually just like sort of wait at the terminal for the user to type something, but the user may not know what to type. Okay, here the user is given the prompt, enter first name, and then they know what to type. Okay. Notice that you have to, your use of the input function will look like some variable equals input almost all the time. If you don't have the variable, if you just have that, it will actually capture the input, but since it isn't saved anywhere, it wouldn't be able to do anything with it then. Okay, typecasting is how we handle the situation where we want to take something from one type of variable to another. Okay, most often this is used when you're inputting a string and you want it to be an integer or a floating point number or something like that. You can also go the other way. If you have something that's an integer and you want it to be a string, you can also say something like out age equals string age, which will convert an integer to a string. And that can be helpful in a variety of situations as well. Okay, and here's basically what I said. Okay, when you're concatenating things together in a print statement, you have to convert any numeric values to a string, or you will get an error. Okay, you occasionally may want to convert things to Boolean too, and you can do that. Okay, print does exactly what you would expect it to do. It takes whatever is given and prints it to the terminal. By default, if you put commas between things, okay, it'll print an unlimited number of those commas or variables, and you don't need to convert things to strings. If you use the concatenation using pluses instead of commas, then everything has to be a string to concatenate together. By default, print will always go to a new line after the final, but there are ways to to override that. And this will just print a blank line. Okay, so let's take a look at a quick example here. Okay, this is a Mad Libs, and Mad Libs you probably recall from elementary school. Basically allows you to write a funny story by asking a unsuspecting victim to give you certain types of variable or values based on their part of speech, and then you print out the story. Okay, so here is an example of the Mad Libs completed. You can see I did this last semester. So I have a series of input statements, okay, one for each variable or placeholder in my Mad Lib. Okay, so I have an adjective 1, animal 2. Notice I'm abbreviating adjective the same all the time. And then I'm taking those input values and inserting them into the story. To make it easier for me, I want the story to wrap like it is here. Okay, but I'm using the separator equals an empty string. Okay, so there's nothing in between the two quotes. Okay, and that will prevent it from going to the next line. Okay, as it would by default. So, and I can also use, single space, which actually might make more sense because it's the end of a sentence. So you probably do want a space at the end of a sentence. You see here, I'm just going to make that change real quick. I'm using idle here to run the program. And there's videos available for that. Okay, so, sorry. Okay, so here my idle screen is asking me for an adjective, blue, an animal, rabbit, kangaroo, a noun, phone, another adjective, large, another noun. I'm looking around my room here, soda, and another adjective, warm, and another adjective, sunny, and finally a noun, hair tie. Okay, so here's my output. Camping is blue. You might see a rabbit or a kangaroo. Food is cooked over the phone, which is very large. The best part of camping is using the soda, which is very warm. At night, the tent is extremely sunny. It's always best to take a hair tie camping with you. So a silly story made up. Okay, but you can see how we're using the input and the print statements. I don't know why this is shoved over like that. Together for that to happen in our, kind of our first real Python program here.